I'm Ennemcien. Let us see what is displacement current. You know that a capacitor, when connected to a DC source or a battery, the capacitor will not conduct current because the core of the capacitor is a dielectric or vacuum. Dielectric is a special kind of insulator, so it won't conduct electricity. But when you apply alternating voltage, the capacitor will conduct. Why? We know that electric field intensity in between the plates of a parallel plate capacitor is sigma by epsilon zero, where the core is assumed to be vacuum or free space. Cross multiplying this, you get epsilon 0 into E equals sigma. Sigma is the surface density of charge or charge per unit area. That is, sigma is Q by A, where Q is the magnitude of charge, total charge on one of the plates, and area is the area of each plate. Epsilon 0 into E, we call it as electric displacement. Electric displacement. So capital D. Just you cross multiply this, you get A into D equals Q. You differentiate this equation. A is a constant, so A into d by dt equals dq by dt. dq by dt is nothing but strength of current, I. So I call it ID. So that means ID equals A into dd by dt. This ID is known as displacement current. And displacement current is given by area of each plate into rate of change of electric displacement. Hence the name displacement current. This is caused by changing value of D, electric displacement. Now D, again D equals epsilon 0 E. That is epsilon 0 into E. Electric intensity is potential difference between the plates V divided by plate separation V by D, work by distance. Intensity is force, potential difference is work equals force into displacement, so E equals V by D. So the D equals epsilon 0 into V by D. Then ID equals, we get as ID equals A into epsilon 0 by D into dV by dt. A epsilon 0 by D is the capacitance of this parallel plate capacitor C. So ID equals C into dV by dt. This is the result for displacement current through a capacitor. Whenever you apply, so this current is caused by a changing electric field or a changing potential difference. When you apply DC, potential difference V is constant. That means dV by dt is 0. So that displacement current will also be 0. But when you apply an alternating voltage is one which changes periodically, and that change is expressed by dV by dt, rate of change of the alternating voltage. The name alternating itself means changing. So this is the reason why a new current is set up in the circuit and the capacitor conducts alternating current. Whatever be the nature of the core, in between the plates, except the core is not conducting one. Now, what is actually happening here? When you apply a voltage, a steady voltage, one plate becomes positive all the time and the other plate negative all the time. But when you apply an AC, polarity of the plates goes on changing. This plate becomes plus and this plate becomes minus at one time. Next time it becomes minus and this becomes plus. That means there is a movement of charge in this circuit. Actually, this movement is the cause of movement of mobile charge. Charge is the current. This is what is happening here. ID, displacement current ID, can pass through even vacuum. So here the space between the plates, even if it is vacuum, this current exists. So displacement current is a special type of current predicted by Maxwell, Clerk Maxwell. And this displacement current is of utmost importance while forming electromagnetic waves. Thank you.